said, you can't change your name.
Thank you so much for everyone for joining us here. My name is Nikki Lee. I'm the youth sales manager here at AI, and I'm so excited to introduce our guest speaker for today, Mr. Korey Kiepert. Korey is an engineer and owner of the Gravity Group LLC, a wind roller coaster company right here in Cincinnati. He has a mechanical engineering degree from Michigan Technological University, and he is working on wind roller coasters since 1999. He has a wealth of knowledge, and he has a long presentation prepared for you today, so please join me in welcoming Mr. Korey Kiepert.
All right, hey, how are you today? Are you enjoying your day at Kings Island?
Yeah!
I know you want to be here riding the rides. I do too. And so I do want to tell you a little bit about engineering though, since it's Engineering Day. All right? So we do wooden roller coasters all around the world. And today I'm going to tell you a little bit about the secrets of our roller coaster design. You know, the secret herbs and spices, the 11 herbs and spices. And with me, I brought two other engineers from our company. Got James Haley and Hunter Lawrence. And so we all work together as a team. There's no one person that can get things done. You have to work as a team. And hopefully at school you have all sorts of group projects, right? And you learn to work together. And so in real life, when you're building a ride like this where there are millions of parts, you have to work together. And so yeah, we've got a little experiment later where we'll see if Hunter and James can work together well. All right, so before we begin, I just thought we'd talk about roller coasters and what a roller coaster is. And you all think maybe Diamondback and Orion when you think of a roller coaster, but really they go back to the olden days. This is a ride called Switchback. And it's basically a park bench going down like an old wooden structure, right? So we've come a long ways from that. But anything that's like an elevated railway that's constructed with sharp curves and steep inclines on which cars roll is, according to Webster's dictionary, what a roller coaster is, right? So that's what you're here today. Like, as a roller coaster engineer, I thought I'd tell you what a roller coaster is. And then what's an engineer? And I found this cutesy picture online where we solve problems with our brains. We use our hands to build and tear things apart. And then we use a lot of tools to get things done. We also, you know, we have a heart. We want to make the world a better place. Like as a roller coaster engineer, like, why do I do it? I like the feeling of roller coasters. I like doing it. But really, coming to Kings Island and doing things with your family, it brings your family closer together. And that's an important part of just having fun experiences together. Engineers, we have to communicate, work together, and we have to be willing to travel. And so, like roller coasters are taking me to China and other places in the world that I never thought I'd go. And the tools that we use, like I have a little engineering toolbox, we use a lot of math, and we use a lot of physics and computers, like CAD software and whatnot, and also a lot of like hands-on tools like survey equipment and whatnot. So I'm basically a roller coaster engineer along with James and Hunter here. So now that I've told you about that, like we do wooden roller coasters at our company, and there's all this. Yeah, we like the racers of wooden roller coasters. What's that? Okay. Yeah, we worked on the races past year at Kings Island a little bit along with the wood coaster crew, and that was a fun project. This is just meant to show you some of the parts. Like there are, we have roller coaster, we have names for the different components, each cross section of the ride. We lovingly design and make sure that it can safely hold you up. And that's sort of our job, is to make you feel like you're doing something unsafe in a very safe way, right? And that we've been successful if we've scared you a little. And we follow a lot of design codes and whatnot, like there are different codes depending on where you're at in the world for the safety of rides, and that's our number one goal. So we have a lot of different parts on the roller coaster, from the track on up, but designing all of that, knowing what the force is, what's in there, It's what we do to make sure that the rides are safe. People often ask how the rides stay on the track, right? And if you look at this right here, apparently my laser pointer is not working. We have a wheel section that James wants to show. Basically on our track, there's a lip on a wooden roller coaster so that when you're in airtime, when you're lifting off the track, there's actually a wheel on the underside that is hauled onto the track to hold you in. As you go through a turn, there are wheels on the side that hold you in place as well. So there's a precision vehicle that, all these roller coasters are that's designed in the off season. There's a lot of maintenance that's done. Every day there are huge amounts of inspections that are done to make sure that the rides are safe. I hearken it like if you're riding on an airplane, you know that there are mechanics that are doing a lot of testing and a lot of maintenance to keep the airplane safe. The same is done for amusement parks. They have a giant staff. It's like a city here, actually. When you look at physics, if you think about some of the problems that you might have had this past year in some of your classes, there's always like a mass on an incline, and you might ask yourself, well, where would I ever see something like that? A mass being pushed up an incline. And really, when you think about a roller coaster going up in Slip Hill, there it is, So I'm not going to get into the physics of it too deeply, but that's the real life application there, So why am I doing this? Well, if you took a job like mine, you have to deal with that on a regular basis. Also, there are these things in math class where you maybe have dealt with parabolas or some complex shapes like ellipses and whatnot. Where would you ever use that? On roller coasters, we want to have the air time, and by having a parabolic shape, we can have longer stretches of air time. And so here's a ride in Sweden where you can kind of see the parabolic shape that was used. So just where physics and math come together in the fun of our everyday life. Here's where we get to have a little bit of fun. But when you're going around turns, you're pushing your seat, there's something called like centrifugal force, centrifugal motion. And here I have someone with a yo-yo, and it just kind of shows like an application of that. But I have a bucket of water here. Hunter, can you take the bucket of water? And what I'd like to do, can you show that there's really water there? Yep, there's water, okay? So we have James and Hunter, and what we're going to do, when you're going upside down on a roller coaster, you ever wonder why you don't fall out? Like, you ever feel like, I should be falling out right now. But really, when you think about motion like this, as you spin, does this yo-yo want to fall in, or is it being pushed out, right? So James, can you come and have a seat here on the floor, and let's see what we can do here. If we have a bucket of water, is it possible for it to go in a circle and be held in place? And be careful, you don't want to be slippery in this. All right, so what we're going to do real fast is we're going to see if we can have enough centrifugal motion to keep the water in place without getting James soaked. Or maybe we want James to get wet. All right, go ahead, Hunter. Oh, just a little bit, but as you can see, it stayed in place. And when you're going around, maybe some applause for James. So when you're on one of the rides here, you're going upside down, and you're being pushed into your seat. Like, it's the same thing as this water in the bucket. The water isn't wanting to fall out of the bucket, it's being pushed in. So just an everyday thing that sort of relates to a roller coaster and what we do. I just wanted to talk about how we design stuff, because sometimes people are like, how do you come up with the ideas? And we have a design process that we go through, a construction process, and all total, this process from the first time we start construction until we open a ride, it can be like a 9-month process. It's kind of like, as a company, we have a baby, it takes time to grow and develop, and then finally it arrives, and it's a joy to everyone. So oftentimes when we have a park, they might give us an aerial view or some information on the site where they want to ride, and then it's our job to listen to different ideas that the park has, like where they might want to put a station, what's important to them. And then what we do is we come up with a couple of different ideas. And so some of these ideas, like on that last site, like we interacted with some water slides, or we tried to take an existing path and put a station so there's good access, like for the flow of people. Or other times, what we're trying to do is we're trying to have certain visibility. Here we are filling some giant helium balloons, and you can't really see them too well in the picture, but what we're trying to do is we're trying to give the park some idea about what kind of visual you might have from that area. So we're trying to be creative in, the skyline here as you come up to Kings Island, that's something that draws you in and makes you feel excited about the day. So that's a part of our design process, is to think about all those things. Here's sort of a rendering that kind of showed how you see this, the tip of the roller coaster kind of behind. Like if you look at these berms and the balloons, that's what we were trying to help them visualize. So after you do the proposal, then hopefully we have a contract and we come up with theming ideas with the park for the trains. And then we come up with the final design of the ride, and then we put the pedal to the metal, and we start the design process, where we have all sorts of programs that we've developed, where we'll come up with the actual layout of the ride. And when I'm designing something, I'm not necessarily looking at the shape as much as I'm looking at some of the numbers. What are the forces that I'm putting on the different people? And by looking at tables and numbers, I have a good idea as to whether a ride will be fun or not. So for us, sometimes it's you got Roller Coaster Tycoon, and there's a little bit of an aspect of that where we'll create animations and renderings to help people visualize what something's like. But a lot of it is just knowing the numbers and getting those numbers right. So, and then we also do a lot of analysis of these cross sections of the ride, where we'll analyze cross sections and then we'll detail up those cross sections and have them fabricated. And as we set those pieces of structure together, our ride takes shape. The train design is another part. Hunter and James have been a part of this team, this world a little bit more. But for everything we do, we create solid models, we create finite element analysis. Is something that is just a way of looking at, is something going to break? Are there high stresses in a part? And what we can do to make sure, like part of engineering is having a safety factor on everything we do, making sure that, even if you feel like something is thrilling or unsafe, we have a safety factor, maybe 2 or more on certain parts to make sure that nothing bad could ever happen. So we're having to think of all these different scenarios when we're designing a ride. During the construction process, there's like a foundation phase where we have to think about how we support the ride in the ground and what the soil conditions are. And then there are obstacles that you have. Like here we had all sorts of water tanks from that water park that was nearby the ride. And then when we construct the ride, we build little cross sections and set them with a crane, and the ride starts to take shape. And all this can happen in a matter of like a year or a certain number of months. And then at the same time as that, we're manufacturing parts for our cars. We have billets of steel that become wheels, portions of cars that we cut out that become the seats or the wheel supports. So there are a lot of team members, a lot of different parts that are going on to all come together. So that when you sit on a ride, there are hundreds or thousands of people that spend time making that come together for you. So, and then we do a lot of assembly of the trains and the mechanical equipment that the chain lifts, the brakes and whatnot that are on the ride. And for a wooden roller coaster, we actually are cutting the track. And there's a lot of wood and manual labor that takes place to get that done as well on site. And finally, we add steel. Like even though it's a wooden roller coaster, it runs on little steel rails. We do testing and add the mechanical equipment. And then there's the control system. Like there's a lot of electronics and computers associated with the rides, so that you need to make sure that if you have one train on the track here and another train in another location, they can never come in contact with one another, right? And so that's done with a lot of computer programming. So there are a lot of different people that are playing a lot of parts on the rides. And then you have operators that use a control panel such as this on the ride. And then there comes the day that you put it all together. You put the trains on the track and you get ready to set the ride for the first time. And we have water dummies and different things that we use that are the first people that get to ride the ride. And then we do testing, or we look at numbers. So this graph here, this is G-force testing, okay? And what we're doing is we might look at, what is the design G-force compared to this actual G-force that we have. And then we say, is our design good or bad? And there are third parties that, look at this information and say, yeah, you did a good job here. And then this is all part of the due diligence to keep the ride safe and make sure that what we designed is actually what we built. And then there comes the day that you brought it to reality and it opens to the public. And it's like your kid has grown up and you pass it off to the park. So, anyways, that's a little bit about the history, like just showing you how a ride got built, some of the engineering process. You guys have any questions at all? Apparently my PowerPoint is stopped, which is convenient. Any questions at all? How much school do you need? To be a roller coaster engineer, like we all have 4-year degrees at different schools. I went to Michigan Tech. We got Miami, and let's say Cornell, but that's not right. Yeah, Carnegie Mellon, yeah. So like 4-year degrees. I have a master's degree in mechanical engineering as well. So at least 4 years. So to be on the design side. Yes. Advantages or disadvantages of wood versus steel. Do you want to answer this, Hunter?
Wood versus steel, advantages or disadvantages?
You mean like in ride experience or in like just like design? I mean, wood is very different, like very, very different from steel. I've always been attracted to wood just because of the aesthetics of it. You can make, different types of structures with wood. It's usually more economical than steel, so parks, kind of are able to maybe do more with their budget roller coaster. I don't know, any bad things?
Wood coasters have a big life structure, it's all about actually sit there, and over the life of the ride, you go through any complications or fix a problematic area. It's not super expensive. But like steel coaster, we drive steel coasters, it's huge money. So wood coasters are customizable and
You want one more?
Just one more thing as far as the ride experience. I mean, and this is, I guess it's opinion, but I don't know. To me, wooden coasters provide a much more unique experience than steel coasters. That's, why I think all of us are attracted to wooden coasters. Every time you're going to get a slightly different ride experience, and I think that's something that only wood as a material is really going to achieve for you.
All right, any other questions? In the far back, yes.
Oh, I'm sorry. What model of software?
Oh, modeling software, yes. We use Autodesk products. So we use AutoCAD, Inventor, some of those. Other people use SolidWorks, and then like ANSYS and programs like that. So yes, expensive software. Anything else? You could try on Tinkercad, I guess, but no, that's an issue. Go ahead, yes.
You see tracking coming up with the arcs and iBox tracking. Do you see guys like tracking in the air future?
We actually have our own prefabricated wooden track. So if you ride the Racer today, or even the first drop of the Beast, it's our own special machine track where like if you go across the bridge, like your picnic table tops, the wood is this, it's like flat ones, right? And if you walk on that, you could bounce on it and it would have a lot of motion, right? And typically wooden tracks are built up that way, right? Flat ones, lumber stacked. What we've done on the Racer and on the Beast in certain portions is we turned that wood 90 degrees and then we pre-cut the shape of the curvature into the track. And if you take a board and stand it 90 degrees on the edge, it's a lot stronger from a bending standpoint. And so our answer is to stay with wood, but use it in a more smart way. So if you take the material of choice, which in our case is wood, and you're just really smart about how you do it, you can achieve results that are similar to some of our competitors. All right, anything else? Questions? Engineering? Why it's fun? Yes? What is the best type of wood to build with? Whatever you have in front of you. Chocolate? No. We use southern yellow pine, which it's good because it's a strong wood, but it also is a ductile wood. That means we can bend and twist it as well. So it has a good balance of properties. And southern pine also takes there's a chemical that we add to wood that's used outside, and southern pine sucks it in like a sponge better than some other wood. So southern pine is our wood of choice. Anything else? My favorite roller coaster is the one I just got off of. I've worked on probably 30 some roller coasters over my career, and I have a fondness for really all of them. The one picture that I showed of the ride in Stockholm, Coaster Adrenaline, was especially challenging, and I just have a lot of good memories about that ride. It was the first roller coaster that my two daughters rode, and so that's kind of got a special place in my heart. Yeah, I mean, we've had a couple. There was Kentucky Flyer, there were pictures of Tenerife Jesus in France, Wood Express at St. Paul. Anyways, anything else? Right? Yes. Well, yeah, I mean, it really depends on the environment. There are some rides that have lasted a long time, like the Racer. There's a lot of the Racer here at Kings Island that is 50 years old, like as old as the park. But there are some other parts of it that they have replaced, every 15, 20 years or so. It all depends on the environment, the forces, things like that. But in general, wood is a great material to build with. So, anything else?
What's the most positive or negative genes you've ever designed for yourself?
The most that we designed for? Well, most wooden roller coasters and steel roller coasters have different limits that most people design to. We're, on the 3Gs, like into the seat, so you feel like 3 times your body weight as you're pushed into the seat. And then in terms of negative, we're often, hovering right around 0. So that's that weightless feeling, airtime, like if you're an astronaut in space or whatnot. Anything else? Am I allowed? Do they need to eat or more questions? More questions? Go. Okay. Just different rides, behave differently. Anything else? Any other questions?
Yeah, I'm trying to think of it. He probably knows them all. He probably knows everything. You can ask him. I'll do a good job, right?
We have rides we haven't done any maintenance on, and then there are others where just depending on the environment, the time frame, the trains, there are a lot of factors that influence things. So, our intent, we develop our own cars, and we change the way we do our track, and everything that we do, we're trying to reduce the maintenance and improve the ride experience, the longevity of the rides. So, anything else? Yes? We worked on anything here, James?
We worked on Beast and Racer here. We haven't built anything around up here, but we've done a ton of work in the maintenance world. So this past off season, we had a Racer on a far turnaround all the way to the brakes. We redid all that track with some of our guys, and then the park also did their own section of we supplied the track. Racer has that RU engineer pickup track on it, and if you're in the tank, that's the right. But the Beast also, we've done a huge version of that. It's really good. Yeah. Really excited. Yeah, we've done a lot here. Good relationship.
Anything else? Go ahead. Yes.
How do you implement steel into your like roller coaster designs?
You mean like steel structure?
Well, I've just noticed that like on like the side of your tracks you have like steel brackets.
Yeah, I mean,
So the bracket you're talking about is, we call that a track bracket. On the lateral G-force and they're not rolling. We put that in the system to stack up so it slides side to side. So that's all based on what we're talking about. That's running the sonar on the ride and looking at the G-force, looking at the design forces. That's all part of it. So high stress areas, you'll see that.
There's a lot of bumpy stickers.
in the back, yes. How long does it take to build a roller coaster? I mean, it depends on the length and the size of the roller coaster, but often a park gives us from the time they close, which can be like Labor Day, until they open again the following year. So often a project is done within a 9-month period to 13 months.
How do you guys get inspiration for your layouts?
How do we get inspiration for our layouts? It varies, really. Like for me, I like to visit the park and I like to talk to the owners and the people that have a vision for the ride and try to capture what they want to do. Sometimes, like in the case of Groenland, where we had a really compact site, there were only certain places we could fit a station and a lift hill, and the ride sort of designed itself in a way. But then there are other times where you get a great big open field, and it's just up to you. I like airtime, so I like that feeling of weightlessness. So I always try to have a lot of airtime when I'm working on something, but different people have different design philosophies, even within our group. Anything to add?
I'm a fan of more like some really like classic elements. I'm from Pittsburgh, Pennsylvania originally, so I grew up going to Kennewood Park. I worked there for a couple years on one of the coasters. They have an old wooden coaster there called Jackrabbit, and that is a perfect example of one specific type of element that you'll see in some of the coasters called a double dip or a double down. And I think that's, I don't know, a really neat element. It's maybe not used quite as common as it has in the past, but there's just specific little elements like that that I think different people have different favorites.
All right. Anything else? Oh, one question, yes. We do, yes, on occasion we've had interns, college, co-ops or interns.
Interns?
It just depends on what's going on at the time. What's that? It just varies. If people are local, it's a little easier sometimes to coordinate something than someone. We try to have people from colleges come in from time to time. Some of our engineers from the past started as co-ops and they just carried on through. So, anything else? Yes? We rarely get to come up with the names for the roller coaster. We get to design the layout to do that, but typically the marketing departments or the park owners get to come up with the names. And so we work on something and then one day we're told, like it starts as just like wooden roller coaster project. And then one day they tell us, it's going to be called this. And we're like, okay, that's its name. It just kind of grows on you over time. So, anything else? Go ahead.
So like how often, cause like how often do you guys have to like go back to like the drawing board? Like does anything not like work out, or like when you're building it, is something not work right? Like
well, the good thing about a wooden roller coaster is it's built, like sometimes the construction and the design can be very close to one another, and because you're using wood as a material, you can make changes like even while it's being built. And so there are certainly, like the ride at Groenland in Sweden, there were 27 different iterations until we got to where we are. And some of those changes are big and some of them are smaller. And then some of them, the casual observer wouldn't notice, but we know what we changed. It's like a little fine tuning of a recipe sometimes. Anything else before you launch? Yes. I mean, the great thing is we're never allowed to talk about anything in the works. It's sort of like roller coasters, or it's sort of like the arms race between the amusement parks. And so we typically sign a lot of confidentiality agreements. My wife and kids don't even know what I'm working on. So, anything else? That's it? All right, Nikki, we're going to let you know.